Okay, in this video, we start talking about probability distributions, which is where we look at probabilities for a particular experiment or process, and we're looking on how these probabilities change or are distributed for different outcomes for that particular process. And probability distributions, there's an infinite number. There's all kinds of probabilities. As long as they follow the rule that every individual probability is a number between 0 and 1, and the total number, if you sum all the probabilities for a particular experiment, if the total probability is equal to 1, that's a probability distribution. And there's an infinite number. We can create, and they exist for a lot of different situations, but there are certainly ones that we want to start with because it's an easy introduction to probability distributions, and also there's some that are incredibly important because they show up on a regular basis in the real world that we can use. If we think about probability distributions, we need to think about what type of data that we're looking at. And again, we kind of cut this into two different types of data. We look at data where our outcome is categorical, where it's either this or this, and we can count those. It's a countable number of clear, mutually exclusive categories. And even though it's an odd, but think about rolling a dice or a six-sided die. I think it's singular. If I roll a six-sided die, I cannot get an outcome of 1.4. The value is either 1, or it's 2, or it's 3, or it's 4, or it's 5, or it's 6. You can't get anything more than that or less than that, and you can't get anything in between. You're not going to get a dice that rolls a 2.78. So we've got a countable number, and they're mutually exclusive categories. An extension of that is something, or an advanced step of that is a binomial distribution, and we'll look at that and examples of that also. And then by far, what we're going to spend several videos on, and the most important thing that one of the most important things to take out of this class as you move on is a clear understanding of the normal distribution, the mechanics of calculating probabilities from it, as well as some appreciation of why it shows up all the time in statistics. So we'll spend some time on that. So for each of these, six-sided dice, the binomial distribution, and the normal distribution, we will have videos on what those are and how to accomplish and calculate probabilities for particular problems. How to do those in Excel. So let's start with the six-sided die. So the first thing we do is that when you run a random experiment, you're going to have an outcome that you don't know what the outcome is. You might be able to say it's going to be one of these, or you might be able to put boundaries on it, but you certainly don't know what the outcome is. That's what makes it random. So when we roll a die, we know we're either going to get 1, 2, 3, 4, 5, or 6. We just don't know which one. So the value that it takes, or the value that it can take on, is a random variable. So we're going to let X, it's unknown, it's going to be a random variable, and what we want to do is say, well, what is the probability that X is equal to 1? Well, that's pretty easy since we have a fair dice, and that's the assumption, is that we have a fair dice, is the probability of rolling a 1 is 1/6, which happens to be the probability if we roll a 2 all the way up to a 6. All probabilities 1 through 6 are equally likely. So the probability, and keep in mind, this is a legit probability because it is a number between 0 and 1, 1/6, about 16 or 17%, if you want to think of it that way. And the other thing that makes it a probability distribution is that if you sum all the probabilities, so if you sum 1/6 for all outcomes, which are 6, you get 1. And that is, so now this is a probability distribution. Those two properties make it so. I want to introduce another term to you that this shows up on a regular basis, and you need to be familiar with what it means. A cumulative probability. A cumulative probability is when we calculate probabilities. Again, that's a number between 0 and 1, but it's a probability of getting less than or equal to some outcome. So look at the difference between the probability that x equals 1 and a cumulative probability that x is less than or equal to 1. That's less than or equal to. Now in that case, since we can't roll a 0 using a dice, they happen to be the same. The probability that you're going to roll and get a 1 or less is 1/6, because the only thing you can get is 1. But look at the difference for 2. The probability of rolling exactly a 2 is 1/6. But the cumulative probability, or the probability of rolling and getting less than or equal to 2, that is a cumulative probability. When I say less than or equal to, that's equal to rolling a 2 or anything less than 2. But you can see it's a probability that x equals 1 plus the probability that x equals 2, which is 2/6. And you can just step this up. The probability that x is less than or equal to 3 is the cumulative probability when x is equal to 3 is 3/6. All the way up, that the probability, the cumulative probability of 6 is 1, because that means the probability of rolling less than or equal to 6 on a 6-sided die is 1. You can get that, that's everything. And we can show this in Excel and then do a couple of, ask a couple of problems. So let's go to Excel. These are our outcomes of rolling a die, and every one of them, the probability is equal to 1/6. Every one of these is 1/6. And so let me do that again. All I did was say equal 1 divided by 6. Excel doesn't show it as a fraction, it shows it as a decimal. So there's the probability, and it's equally likely. So I can calculate a cumulative probability from these. And look what I'm going to do. The very first one I just bring over. So the probability, the cumulative probability, of 1 is the same as this one. But what is the cumulative probability? The cumulative probability of a 2. Well, it's summing these two, or the way that we can write a formula that we can copy down, it's equal to whatever the cumulative probability above it plus the individual probability of that particular event. And I can take that formula and copy it down. And again, let's get rid of all these crazy decimals and show maybe just 2. So if I look at one of these, like this one, the cumulative probability that x is less than or equal to 4, where your little x is 4, so the probability that x is, which is what this is, just to make sure, this is the probability of x is less than or equal to 4, is what that is. It's 0.67. How did I calculate that using Excel? Remember what it is. It's the sum of all these, or an easy way to do it, it's equal to the cumulative probability of the previous outcome plus the individual probability of that outcome. And if you do this right, the sum of this is always equal to 1, and this last value is always equal to 1. You'll get the same thing. So let's solve some problems. What's the probability that we will get an even number? Well, that's equal the probability that x is equal to 2 plus the probability that x is equal to 4 plus the probability that x is equal to 6. I mean, that's the equivalent of what I'm asking for, and that's an easy thing to calculate. We could just take this plus this plus this, or you could certainly have done that in your head and get 0.5. 50% chance to get an even number. A little bit more difficult. What is the probability of rolling and getting a number that's greater than or equal to 4? Now the answer to this is, well, this is equal to, there's lots of ways to equate this. This is a probability that x is equal to 5 plus the probability that x is equal to 6. That's the easiest way to think of it, so that's going to be 2/3. Here's another way I want you to think about it. This is important. When you see greater than or equal to, so I'm going to start this over. When you see that, what's the probability that x is greater than or equal to 4? We can rewrite this in the form of using a cumulative probability. Because the total probabilities have to sum to 1. If we're looking at one side of 4, we can say that that's also equal to 1 minus the probability that x is less than or equal to 4. The probability of getting bigger than 4 is taking 1 minus of getting x less than or equal to 4. So I rewrote this where, since I already have a cumulative probability calculated, I can take advantage of that to solve this. So that would be equal to 1 minus the probability that the cumulative probability that x is equal to 4, which is this number. And again, I get the same thing as that if we would have just done this plus this. But I promise you, thinking this way is going to help you as we move on to more complicated probability distributions. When you see the greater than, you can think that I can rewrite that in the form of a less than or equal to by knowing that the total probabilities have to sum to 1. So I can say 1 minus, I would call this the right-hand side. I can rewrite, or the right-hand side is equal to 1 minus the left-hand side. Okay, thanks.